So for that makeup quiz, so starting with number 23.
Can you read the other packet from Friday? If you go, I won't do that.
This one's pretty simple. What? Question?
Are they the same questions from the last test?
Yes, that makeup points thing is going to be a subsection of the ones I go over here. It won't be all of them, it'll just be a few of them. But starting at 23, going all the way through to 33, skipping a few. It won't be the exact same. I mean, this will be a different number, but this is how you would do it. On the periodic table, you'll see that for nitrogen. So 2.48 moles of nitrogen. The moles on the bottom, grams on top. 1 mole of nitrogen is 14.01 grams of nitrogen. That'll do it. 2.48 times 14.01. I guess that was 34.7.
Question. Can I come back to you a second? Can you go for number 7?
That one won't be on the quiz.
Okay.
We won't go that far. This is we skipped some of these. We skipped 26, 29, 30. So that's 10 questions. It'll be a subsection of those 10.
Hey, can I ask a quick question? On the theatron, how do I know if the one I got wrong is the one the left is right? It lines up.
To the way it lines up. If it lines up with the left, mine's okay. So that's how you calculate this. Okay. 2.48 times 14.01. So yeah, 34.7.
And I got 34.
Number 24. Look up rubidium on the periodic table. That's down here, so 85.47. Grams per mole. So we'll go 0.816 grams of rubidium. We need grams on bottom. .816 divided by 85.47. That's the answer. That's the answer in the standard scientific. Okay, number 25. Tell me if I'm erasing too fast. How many moles of aluminum are in atoms? Here, all you need is 4.88, 10 to the 26. So maybe you can do the exponents in your fancy calculators over there, but I would do 4.88 divided by 6.022. Three significant figures, 4, so I'm going to go 29.4 times 10 to the, I've got 10 to the 26 on top and 10 to the 23 on the bottom. I want to move that up to the top, which is going to change the sign. So times 10 to the negative 23, which equals 10 to the 3, equals 10 to the 3. 4.8, 6.022. Did we skip that one too?
We skipped 26.
Yeah, but I don't see it on. Huh? I don't see the answer there. How did I grade this? 4.8 divided by. Oh, I calculated it wrong. That's not right. The 10 to the 3 part was right. I miskeyed in my calculator somehow. This was 0.810. So 810 moles essentially. All right.
Professor, can I make a special request? Can you go for 31? Because that was like really the only one that made sense.
Yeah, I'll do it. We're on 27. That was 26. Sorry. That was 26 we just did. No, we skipped 26. Yeah, we skipped 26. So we go from 25 to 27. Made 12.6 grams AgNO3 grams. Given much this is made when this many grams this. I also gave you AgNO3. Also gave you and that helps you along. All right, you take what you're given first, 12 grams of AgNO3, 12.6 grams AgNO3. Next, you're going to use your grams per mole here. Grams on the bottom. One mole. Next, we're going to use the molar ratio between this and this. We need moles of AgNO3 on bottom. So 2 moles AgNO3 to 1 mole and last we're going to use this, and that'll give us the grams of the AgNO3. 261.34. Moles on bottom, 1 mole. That'll do it. 12.6 times 261.34 divided by 169.87 divided by 2. 3 significant figures, that's exact, those are exact, that's exact. 3, 5, 5, so my answer needs to be in 3. Let's do 28. I mean, the moles of interior to produce 5.94 moles of steel. So you ask for moles and you're given moles, so you don't need the grams per mole. I thought she wanted me to do everyone. So you start with 5.942, and you just do your molar ratio between O2 and CO2. Moles of CO2 on bottom. O2 on top. That's 7 moles of O2 to 4 moles of CO2. Exact. 3 significant figures. 5.94 times 7 divided by 4. Calculator says 10.395, but it's going to be 10.40 moles. All right, 3 more. Skip 29 and 30. 1. Things to pull out here. The capital M means 2.55 moles of NaCl in 1 liter NaCl. So you start with a 5.69 or 0.569 liters. And then you just use that as is, 2.55 moles. I didn't give you the grams per mole of NaCl. We'll have to calculate that. I'm going to need chlorine. Na is 29 something. 22.99. .44 grams per mole. That's how you do it. So there's the liters that you were given. This is the 0.255 M. Just break it out into moles over 1 liter. And of course, this is the molecular weight. 0.569 times 2.55 times 58.44. Calculator says that's exact. 3 significant figures, 3, 4, so this needs to be rounded to there. 4, 8. All right. 2. $355 milliliters of 0.561 molar solution is is the equalizer velocity. You just have to identify what is M1, what is V1, what is M2, what is V2. It says final volume, so this is what we're looking for. 355 milliliters of a 0.561 molar solution, and this one is 0.250, and then you just plug and chug. We're solving for V2, so I'm going M1, V1 divided by M2 equals V2. M1 is 0.561, V1 is 355, M1 is 0.250, M2 I get. So those are all three significant figures. So 796, 62. 6 rounds to 6, so 797. And that was in milliliters. All right, one more. Also given 2 KCl plus PbNO3 So we'll use the molar ratio, but remember 0.155 is moles per liter. We want to start with these things. So, 250 liters of PbNO3 to solution. And then 0.175 moles PbNO3 to 1 liter PbNO3 to solution. So that gets us to moles. Now we're going to go, we need moles of PbNO3 on the bottom, so this is the 1. One mole of that, 2 moles of KCl right now. And now we have 0.155 moles per liter for KCl, but we need the moles on the bottom, so it's 0.155 moles KCl in 1 liter KCl solution. That'll give us liters of KCl solution. What is the volume, aka liters, needed? That'll do it.
Wait, for this one, why didn't we just do, like, use the same formula for the others, like M1, V1?
Which one? When you say the others?
Like 32.
That's a dilution. There's not even a reaction there.
Okay.
So that one's done by M1V1, M2V2. The one, if you go back to the previous page that had a reaction, what am I thinking? If you look back at number 27, those you have grams per mole to work with. And you're not dealing in any liters or any concentrations. This one, we have volumes and we have concentrations. For number 27, we have grams and grams per mole. Another way to say it is we have liters and moles per liter for this one. For 27, we have grams and grams per mole for that.
So it's the same thing, just different units.
Yeah, essentially.
Thank you.
And then plug through this. That's exact. 3 significant figures. 0.250 times 2 divided by 0.155. So I get 3.2 some subset of those that I just went over will be on that quiz.
Wait, it says the answer is 0.56.
To the 1. Is that what's counted as correct?
Yeah.
Let's look at it a second. I had C. Volume 155 mole per liter. And it's 1 mole of that to 2 moles of that. 175 moles per liter. Oh, I left the 175 out when I calculated it. Let me do it again. 0.250 times 0.175 times 2 divided by 0.155. 565, is that what it is?
Yeah.
Yeah, that's not right. What I did was missed some digits. My calculator says 0.564516. I'm keeping those, the 5 rounds of the 4, so this actually comes out. Yeah. Good. Yeah, I just glazed right over that. I didn't enter it in my calculation. All right. All right, so that's going to be the makeup quiz. It should be time to do our test.